Welcome everyone to the last lesson in the full-time GoDev program of the introduction chapter, right? Of course, not the last lesson, but for the introduction of Golang, we are finishing up. And we're going to cover testing in Golang. It's a very important aspect once again. And I'm going to show you the basics of how to set up tests, how to test. And we're going to, of course, use testing a lot of time in our projects. We're going to also test our HTTP handlers and everything in our JSON APIs, but that's a little bit more advanced, so that's for later in the program. So basically, testing in Golang is actually super easy, right? So what we're going to do first is set things up. So we're going to make a function, for example, func calculates, actually we could do it like that, calculate values, right? And we're going to give x is going to be an integer and y is going to be an integer. And we are going to say, we're going to return an integer, by the way. We're going to make things simple, right? Just to give you an idea. And we're going to return x plus y or something. Something very simple, right? And we want to test this function, right? So how are we going to do that? Well, it's very simple. What we're going to do is we're going to open up, we're going to create a new file, right? This is main. This could be any file name what you want. In this case, it's main because just a main function, right? So what we're going to say is we're going to create a new file. And in Golang, it's important if you want to let go test your files that you basically prepend underscore test on your file. So for example, what we're going to do is we're going to say main underscore test.go, right? That's super important. Underscore test.go. We're going to press enter. And it's going to say package main. That can stay the same. Import testing. You see, it's my Vim plugin already made some things. I'm going to delete this function because I'm going to explain it, right? So we're going to have this package main. So the first thing we're going to do, if you want to test a function, I'm going to, I'm going to basically open up my main here. You guys can see that, hopefully. So you're going to see we have our calculate values. So what we're going to do is we're going to test this function. So we're going to say func, right? And then we're going to append test. This is very important, right? These first four letters should always be test with an uppercase. So we're going to say test, and then we can call this test whatever we want. But because we are basically testing calculate values, what I always do is test calculate values, because that's exactly the function we're going to test, right? But it could be anything, right? So we're going to say as long as there is test in front of your name, the first four letters, right? If that makes sense. It's like the most simple things, explaining the most simple things, sometimes complicated. So we're going to say test calculate values, right? And what it's always going to take is it's going to take a t, and that's going to be a pointer to a testing.t. This is Golang internal, right? That's very important that we do a t, testing.t, or you could actually call this t whatever you want, but everybody's calling it t. So we are also going to call it t. So test calculate values is going to be t, testing.t, and it's not going to return anything, right? So let's delete this. This is our test, right? So what we're going to do is let's print out something here, println, and we're going to say hello from our test, right? Just like that. So how can we test that? Well, we can test it in a couple ways. We could do the go command. If you do go help, for example, we're going to see here, test packages, right? Test, so we're going to try that. So we're going to say, let's clear terminal. We're going to say go test. And what we need to do, there are a couple of things we can do. But if you want to test your whole project, that's something I always do, is this. We need to specify test me everything, right? Test me everything is /./ basically means test everything inside of this directory. That's what it means. And that's it. And we're going to press enter. Wait, it's going to be go test /./ something like that. It's not. All right. Okay. It's telling me that we need a go mod. So we're going to say go mod init. You guys already know what a go mod is. We already covered that. So we're going to say go mod init. It could be anything foo, bar, pass or something. We don't care, right? And now we're going to say go test /./ boom. And it's going to test everything. Right? And it's going to tell us that basically the tests are passing because we didn't specify a fail case, right? We didn't specify anything that Go can derive that the test is failing, right? So, of course, you can already mention that we did not see our hello from our test, right? It's not printed out. Why is that? That's because we didn't specify a verbose flag. So if you want to log inside of your tests, if you want to print inside of your test, if you want to have a more verbose output inside of your tests, we're going to say go test -v from verbose dot slash dot dot dot, press enter. And then you're going to see that it's printing more information onto our screen, right? Run test calculate values. This is our print case. And then it's going to tell us that this test is passed, right? So we could do a lot of things, right? We could say here, we could copy this function, this test function. We're going to say test calculate values special, right? We're going to say hello from our special test case. And if you run this command again, you're going to see that it's going to run this calculate values, this first function, and then it's passing, and then it's going to run calculate values special, and we print out the special test case, and it also passes, right? So how do we fail? Well, in Golang, you can fail a test case by this. You could say t-fail, for example, right? And if you run this, it's annoying that Vim is always, yes, okay, cool. So if we do this, we're going to say fail. You see, where is our fail? Test calculate values here failed. Of course, it fails, but it doesn't tell us what's going on, right? Because that's what we need to do ourselves, right? So let's delete this value special, and let's basically test actually our main function here, this calculate values here, right? Let's test this. So what do we know about this function? We know that we take in 2 arguments, and basically this function is going to be x plus y, right? So what we could do is, what I always do is I'm making a var here, right? And I'm going to say expected is going to be 10, right? That's my expected value. We're going to say A is going to be 5 and B is going to be 5, for example, right? And then we're going to say if, wait, we could do something like half is going to be calculate values A and B, right? And then we're going to say if half is not equal expected, then we're going to say T, and we can also do something like error F, right? Error F is basically print me an error, but a formatted error. And we're going to say, what's going on? We're going to say expected percentage D, because we are working with integers, but half percentage D, right? And we could say, what do I expect here? I expect expected. And what do I have? I have this value from my test, right? Yes, let's run this test. And it's passing. Why? Because this is just an add calculation, right? So we're adding A and B, it's 10, and we expected 10, and we have 10, so everybody's happy, right? But if we do 4, for example, and we run this again, then we're going to see that this test is failing, right? Why? Now we have some information. Expected 10, but have 8. So we know there is something wrong with our calculation, right? Oh, it's my value here is wrong or something, whatever. You get the point. That's how you basically test stuff, right? It is not big of a deal. It's just that, right? Everything is there for you. Just compare, and if your case failed, then you just do a T error F, right? Or a T error, or you just make an error and it will automatically fail the test, right? So some small tips I could give you. For example, let's say we have a type. Let's say again a player here is going to be a structure, right? And this player is going to have a name, which is going to have a string, and it's going to have an age. Or no, a name and HP, for example, is going to be an integer, right? And For example, you want to test two different players if they are equal. How do you do that, right? Because otherwise you need to check if the name is the same, the HP is the same. So what we're going to do is, for example, test equal players t testing dot t. And we're going to say player A is going to be a player, right? And we're going to say that the name is going to be foo, or we're going to say Mark, right? And the age, no, it's not age, it's HP is going to be 100, right? And let's say we expected is going to be player Mark, right? But we're going to have from our test case, right? It's going to grab a player from a database or something. I have no clue. Or some collision check. Who's going to tell us? You name it. We have another player, right? And it's going to be, for example, the name is going to be Alice. Wrong player, right? Because we expected Mark, but we have Alice here, and HP is going to be 101 or something. That's impossible. 89, 59. I mean. So how would you compare these two players together, right? You would make something like what a lot of people will do is this, right? They're going to say if expected dot HP equals half dot HP, well, not equals, by the way. You see, then it's going to say t dot error f, yada, yada, yada. And then we need to do the same thing for a name. And then can you imagine you have 20 fields? You need to compare all of these 20. So how are we going to do this in a very simple way? Well, there is something that is called reflect, right? You could say if reflect deep equal, right? Reflect dot deep equal. And then we're going to say expected and half, right? And we're going to say if they are not deep equal, then we're going to say t error f, right? And then we're going to say percentage, then we're going to say the same thing. We're going to say expected percentage plus v, but got percentage plus v, right? And then we're going to say expected, let's kill this screen here, expected and half, right? And then we're going to run this thing. Let's clear the screen. Let's run this, boom. And we're going to see expected Mark, name Mark HP 100, but got name Alice 59 HP, right? And if we change this to Mark here, and we say 100, right? So annoying here, yes. Then all the tests are passing, right? Okay, that's basically it. That's how you can easily compare deep nested objects in case you need it, and you might need that in the future for sure. That's basically the most simple way to test. There is some other things I could tell you. For example, let's say if you're in VS Code and you have the Go plugin, which is basically standard installed, you can, in your test cases, there will be here above, there will be run test or debug test above, and you can click it and it will run your test, which is easy. But for the people that also using Vim or something else, and you want to only run test players here, because if we do a Go run and we test everything, right, -v, then it's basically Go run. What am I doing actually? It's going to be Go test, by the way. If you say Go test /.. -v, then it's basically going to test and equal players and calculate values, right? But what if you just want to test as one test instead of all these tests, right? Because let's say you have 100 tests in your project and you're basically doing a pull request, you're fixing a bug or something, you just want to test this specific thing. You don't need to run your 100 test cases, right? So how do you do that? Well, you could do it with Go test, right? And then we're going to specify where it's going to test, which is basically this folder, right? To be honest, I think it's going to be // if I'm right, correct me if I'm wrong. And then we're going to basically say min run, and then we're going to specify the name of the test, and it's going to be test equal players, well, like that. I think that's going to be the case. Okay, it's not very clear, so we're going to do a -v here, -v. Yeah, you see? So basically right now it's only testing equal players instead of the whole shebang, right? So let's say we want to, if we want to test, how is it other thing called? Calculate values. We can say test calculate values, right? And we press enter and it's only going to test calculate values. Another cool trick I'm going to show you, which basically not a lot of people know, and that is that each time you run a test, it's going to cache it, right? If you run a test and you're not modifying your test and you keep running that test, it's going to use the results of the cache, right? But that's not always a good thing to have, because sometimes things could happen in your application that are, although your test case stays the same, but the spectrum of your test could change underlying. So that basically means although you never changed your code, your test code, it could be that it could fail by above or underlying code semantics. And that's annoying, because each time you're going to test something, you want to test something and you want to test it again. You see it's cached, right? You see it's cached, right? And I want to do it again, right? For example, I want to test it again. It's cached. So I cannot really test good because it's always giving me this cached version, right? So how can you fix that? Well, you could do something like min count, right? You could say dash count equals 1. It doesn't really matter how much you put in this count, but it makes sure that this nasty little trick makes sure that it's not going to cache, right? And you press enter, you see, and it's basically retesting it all the time without using the cache. Just like that. You see again, boom, no cache, boom, no cache. You see what I mean? So that's something you can note in your textbook. You will use that. It's super handy. It's super handy because, yeah, it is what it is, right? Okay, so this is basically the basis of testing. We are going to use testing in depth. We're going to test HTTP handlers. We are going to test more complex stuff. But like I said, I just give you the basics right now, so it's much more easier to follow. You could already experiment with this. And like I mentioned, if there are questions, don't hesitate to jump into the Discord. I'm going to make a separate channel for the full-time GoDev program where you can discuss all your questions and I will try to answer them as much as possible, right? Don't be afraid to ask questions. Yes. Yeah, so this basically, hey, if you completed this lesson, congratulations, you basically completed the whole introduction in Golang lesson. It's very, like I said, I could go more in depth and it could take longer, but this is just to give you the basics, right? Especially for the people that don't have any experience, to give you the basics of Golang, to let you test some stuff and to make some logical connections. But the real deal is coming after this video, right? We're gonna go into concurrency, and after the concurrency thing is done, we're going to dive into our projects. We're going to build JSON API, and we're gonna build microservices and blockchains and everything, right? So thanks for watching, and I see you in the next chapter, actually.